Good morning, dear student. First of all, I would like to apologize for the delay. I really struggled to log on the system. It was not really easy. I've been struggling. Finally, I succeeded. Okay, so yesterday we were discussing about this Chebyshev function, or Chebyshev polynomial. We saw that the Chebyshev polynomial can be defined as cosine of n, or Tm, m being the degree. The subscript here represents the degree of the polynomial. So it is cosine, and the argument is m into cosine inverse of x. And I explained that the cosine function itself is not an invertible function. You agree with me? It's periodic, so you repeat itself. That is for different values. You have the same. For different values of x, you have the same image. So this already tells us that it's not an injective function. Whereas we know that a function that is invertible is injective and surjective. So if a function is not injective, consequently it's not invertible. But in order to define the inverse or an inverse of the cosine or sine function, we need to restrict it into an interval where the function is invertible. So that's what was done for most of the trigonometric function for which you have the inverse. It's not defined for the entire x value, but it's restricted to a particular interval. Like in the case of cos inverse, it is restricted in the interval 0 pi by 0 pi. In that interval, the cosine function is invertible. It's strictly monotone. Yeah, the function is strictly monotone. Therefore, you can define its inverse. It's continuous and strictly monotone. So the inverse can be defined. So that's what we do, particularly for the Chebyshev function. That's why you have to bear in mind, because each time you're dealing with the Chebyshev function or polynomial, you have to bear that in mind. Okay, so we use this recursion formula, which is a consequence of the trigonometric identity given here. We could write Tm plus 1 in terms of the two previous terms of the sequence, Tn and Tn minus 1. Right. And with this one, if we take into account the fact that T0 is 1 and T1 is x, then recursively we can define all the Tn. And we can see that Tm is a polynomial of degree n. Even though it is written in terms of trigonometric function here, when you expand, it gives you an actual polynomial. And these are a few terms of the. We have T0 is 1, T1 is x, T2 is 2x squared minus 1, T3 is 4x cubed minus 3x, T4, and so forth. All right, now when we define the dot product of two polynomial, this is the definition. It's a weighted integral, right? Weighted integral, the weight is 1 by square root of x minus x squared. And obviously, you agree with me that these are the limit of integration. X cannot take the value -1 and 1, otherwise this integral will explode, right? It will be singularities. There will be -1 and 1 will be singularity. So they are endpoints, so we assume those two values are not reached, right? The interval is open when you integrate it like that. Okay, so this is the interval on which cosine is defined to be invertible. So you always have you have a 1 to 1 from 0 pi to negative 1, 1, that interval. You have a 1 to 1 restriction. And that's why you define your inverse. So you know that cosine inverse is defined from the range to the domain. So that will be from negative 1, 1 to the interval 0 pi. So this is important to know because when we will be applying the change of variable here to integrate, we need to have these two intervals. We need to know the definition of cosine inverse. If you don't know that, you will not be able to make the change of variable. It's really important. Okay, now this is where we stop, right? We stop here. This is where we stop. We're supposed to substitute the values and integrate. So we can proceed from here. So you agree with me? By definition of Tmx and Tnx, you can substitute the values there, right? Because remember that I can let this to be theta, which is an angle. You see? Cosine inverse brings you to the domain of cosine. So it becomes an angle for cosine. So this is our theta. So we call all these theta. So that's what we have here. So if I write this in terms of theta, I need to change, because remember that the variable of integration here is x, and x runs from negative 1 to 1. Now, if I use, instead of x, I use theta, I need to also change the range, right? Because the new variable will be theta. So that's what we are doing here. From here to there, we move from x to theta. And for that, I use this change of variable. So if I use this change of variable, dx, I differentiate, this is what I get. So this dx here becomes negative sine d theta. You see that the variable now is d theta. So we are changing from x to theta, right? And for that, we also look at the value of negative 1. We see 1 will become negative 1 and 1 will become 1 in terms of theta. So we can see that if x is negative 1, cosine inverse, which is our theta, theta will become 0. No, it will become pi instead. You don't look here, but you just substitute, where are we? We are here. So if I replace negative 1 here, I'll have negative 1 equal to cosine theta. So what is theta? Theta will be cosine inverse of negative 1. That is theta. So what is the angle for which the cosine is negative 1? It is pi, right? Cosine of pi is negative 1. So you put pi here directly, because the first limit is negative 1, and it will be transformed to pi. You put pi there. Similarly for 1, 1 will be transformed to 0. Because cosine of 0 is 1. So that's what we put there. But you see that this is not the correct order. You need to change that order. The normal order is from 0 to pi. And if you change the limit of integration, you know that if I integrate from a to b, if I change, it becomes negative integral from b to a. So that's what we do here. So when we change from 0 to pi, there will be a negative sign. And that negative sign will cancel this negative. So negative, negative become positive. That's why here I put positive. right? So it becomes positive here. Okay, so that's what we have. Okay, now here in the denominator, if you use this, you substitute this into that, it becomes square root of sine squared theta. Be careful. If you don't write the correct value, because when you substitute, we know that square root, in fact, for those of you who still know it, square root of x squared, remember that this is a positive quantity. You cannot say that it's x. If you say that it's x, it's wrong. Why? Because x can be -1. If I have square root of -1 square, if you say that is x, you are saying that it's -1. So that would be wrong. Okay, because this is x is -1. If I square -1, square root is not -1. So that's why if you write square root of something square, it's not that something. It is absolute value. If you put this, is wrong. So it is absolute value, and that's correct. Be careful. If you don't pay attention in mathematics, you will think that you are writing correct. Therefore, they are all wrong. So everything, every little information from high school that you know about mathematics should not be forgotten. Because if you forget anything, you'll be writing nonsense. Everything from high school mathematics till now, you need to remember them. Nobody will recall that for you. All right, so that will be absolute value of sine theta. Now you need to know that theta here is between 0 and pi. Of course, between 0 and pi, sine theta is positive, so we can remove the absolute value. Otherwise, you will not remove it like that. If this interval were still, if you had, let's say the interval maybe pi to pi, right? Pi to pi, in this interval, this is negative. So you have to be careful to know. You have to know which interval you are in. If it's an interval where this is negative, if you remove the absolute value, you have to put negative in front so that it becomes positive. You have to be careful of whatever you are writing in mathematics. Okay, so because sine theta is positive here, you remove, and then you cancel this sine theta with this sine theta, and then you are left with this. So you see that you don't just write things because you want to write them. You write things that make sense. Okay, now from here, the rest is up to you. From here, anybody can do this, so I will not do that. You do this yourself to get the values of so from here, I've done the hard work. Now from here, you should be able to do that yourself. Now from here, you should show that if m is different from n, if m is different from n, you can expand this. When I say expand, you can write this as a sum, right? You need to convert this product into a sum, right? Convert this into a sum using a trigonometric identity, and you'll be able to find that this integral, which is that, will be equal to 0. Because if this is different from that, you'll be able to write this in terms of cosine m plus n theta and cosine m minus n. Because they are different, that one will be also non-zero. And therefore, you'll be able to divide by something of m minus n, something like that. So just use that trigonometric identity to do this. And you'll be able to show that this is 0. Now, if m is equal to n equal to 0, then this will become 1. Because this will be 0, this will be 0. Now, if you integrate this, right, it will be the integral d theta 0 to pi. So if you integrate this, you see that the result is pi. So if you do that, it will be equal to pi. And now if they are equal, but not 0, if m is equal to n, you agree with me that if m is equal to n, this will become cosine square n theta, right? You use the identity where you'll be able to write this cosine of 2 n theta. That is double angle, right? Because remember that you can write cosine square x as a function of cosine 2x. So you use that identity to transform this. And you know that you'll be able to integrate that easily using what you did in calculus 2, right? Then you'll be able to integrate that. Knowledge of calculus 2 will help you here. Then you integrate that. So that knowledge of calculus 2, if you integrate that, it will give you pi by 2. Easily. And that is all. That is it. That is it. That is it. There is no magic here. Just a bit of effort. You have all the tools. Good. Okay, so that is it for that identity. I mean, for the property of the orthogonality. We can see that this is orthogonal. This already, it shows you that the Chebyshev polynomial are orthogonal, right? And for the other values, you have a constant term here. And this will allow you to easily solve your least square method. If you use your Gn to be the Tn, the Chebyshev polynomial. If you use a Chebyshev polynomial as your basis of the class of function, then your least square method, particularly the normal equation, becomes easy. You will not even invert. You compute that directly. You compute that directly. When n is equal to n, the coefficient of cj will be pi, and then you divide the right hand side by pi. When they are equal, different, you divide the other side by pi by 2, or you multiply by 2 by pi. You see, normal equation becomes really easy to solve. Yeah, so that's the main features of that. I hope it's clear for everybody, like crystal. It is clear. like a spring water. Oh, spring water. Oh, shit. I even forgot. It is clear like this. I can see through. It is really clear. It's not like which type of water. But in Vambuland, water is really clear. It's clean. Clean. Okay. That's why you eat nice mahangu. All right, all right, all right. And bamboo chicken and damara goat. Okay. Is there any question? Okay, let me give you room to ask question. Just towards the end, if I say, oh, is there any question? People are rushing already for the next class. Okay, you can ask your question, guys. Is there any question? Any concern? Or you want me to give you Vambo chicken before you ask a question? If it is clear like a crystal, just say that's it's so clear, man. Okay, then I will proceed. Class rep, you are there today. I hope you are there. I hope you are not doing what you did yesterday. Okay, tell us. Class rep, if you are there, say hi.
Yes, sir. I am here today. I've been having technical issues, sir.
All right, all right, all right. Technical.
Yes,
But it
I.
was not mechanical. It was technical, but not mechanical, right?
It was technical, not mechanical.
All right, all right. Thank you. Okay, is everything clear? At least you represent the class. Tell us.
Yes, sir. Clear like sparkling water.
Wow, 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 wow. That's great. You say it well. Okay, now we can proceed with our class. Okay, let me share the notes, class note with you so that I proceed. Um, Kashopi.
Sir, did you accept?
Yes.
Sir, you called me.
Yes. To ask you, I'm calling to ask if everything is clear.
Oh, yeah, it is.
Okay, okay, okay. So this is what we cover. We just covered this. All right, I did this already. I completed all these things. And if you recall also the coefficient, the leading coefficient, I showed that it was 2 to the n minus 1. Okay, so there. Okay, now what we are going to do, we are going to show this important property. Right? We know that Tn, the degree of Tn is n. We know that. But the other information we are getting from this is that even though, yes, it's, the degree is n, but there are exactly n roots for each one. So there are no double roots, exactly n distinct roots. Distinct roots. We are going to prove it. And for this, of course, you need your knowledge of trigonometry. The knowledge of trigonometry, yeah? You can see that trigonometry, what you learn in trigonometry, is applicable here. So don't jump or celebrate because, oh, I passed that module. Even though I was not understanding it nicely, but at least maybe you look left, you look to the left or to the right, who knows? How you pass the module, I don't know. I'm just saying. You know what you did to pass. I'm not saying that you did this or you did that. You know, and your neighbor knows. But this is the place where you have to show that you know, huh? You need to use your knowledge in trigonometry to solve. But because I don't want to embarrass some of you, I will not ask you to do that, to solve it for us. I will not ask you to do that, otherwise you'll be crying, and some will even disappear. Surely, if I say, hey, you guy, you, if I pinpoint somebody, hey, you, hey, solve this, hey, you will disappear. You'll be disappearing and saying that, oh, my internet connection had a problem. So when you call me, I was no longer there because my connection had a problem. You just sneak out like that. You disappear. Good, but I will not embarrass you, so don't be scared. We will just proceed. All right, all right, all right. So you see, this was there since last year. I left this. I left this graph. You can see this figure. I left it. Yeah, I'm the one. You can see I drew it. Yeah? You can see this one. This is my doing. This one. It's me, man. It's me. All right. So we are here. Yeah. Huh? Yeah. Oh, trigonometry street, Oh, you can do this and drink a cup of coffee since it's cold now. Unfortunately, I don't have coffee around. Oh, it would have been nice to have my cup of coffee around. I say, oh, you do like this, you do like that. Oh, I drink my cup, my coffee or tea. Oh, because it's cold, man. And you can see the way, yeah. People might think that I'm an Eskimo. I'm not. I'm an African. I'm in the southern Africa. Okay, so at least I will drink my water, even though I don't have a... Okay, so TNX. You know, to get the root, you set equal to 0, right? TNX equal to 0, and we want to find it. There's no witchcraft about that one. Everybody can close your eyes and write TNX equal to 0. So that's what we are doing here. You close your eyes, you write it down, and we know that TNX is TN theta. We know that theta is cosine inverse x. So this equal to 0 imply what? That's where this graph becomes important. Because if I ask you, you are looking at me. If I ask you, that if I covered this and I ask you, what does this equivalent? What does it imply, or what is it equivalent? Oh, sure, I did that long time ago, man. Long time I forgot. As if you even knew, huh? I forgot. So I'm having a problem. My connection. So I'm no longer there. Okay, so cosine something is equal to 0. Now let us come back to this. Okay, due to the fact that cosine is a periodic function. Periodic. What did I say? I said periodic. This is periodic function. It will be doing this forever and ever. So meaning that if you are locked into a room, you are abandoned there even after a century. We assume that in the meantime, you are still alive. COVID will not visit you. Hunger will not. Of course, you are supplied with food and everything. After 100 years, for those of you who are not married, in the meantime, maybe your parents will go and negotiate for you to have a spouse, and then the spouse come and meet you there. And you have children during those years, and the children will come and help you forever and ever. Periodicity. So you start from negative infinity. From negative infinity. Okay, let me use my pen from here. Oh, yeah, it's already selected. Good. Now, periodicity means that it will be doing this. You see, that when it's infinity, you can go that forever to the end. Oh, no, like this. Oh, my God. Okay, but assume you can fix it with your eye. That it is correct. But it's not like this. Huh? You can see what I put there is not correct. Oh no, my God. Okay, let me delete that one. Huh? Okay, periodicity means that you start from negative infinity there. You are not yet born. Negative infinity. Maybe that was your great grand. No, maybe your the ancestor of the ancestor of your ancestor, his ancestor, the other ancestor, the ancestor of the ancestor. Bam, back to okay, when everything started. In the beginning. Start from there, that's negative infinity. Farther. You see, since that time, you have been doing that with cosine. He has been doing this since the beginning, huh? Of course, this is disturbing. But same height, eh? Fix it with your eyes. Okay, I will just continue. Of course, you understand what I mean? Forever and ever and ever and ever and ever, infinity there, in front. You can add thousands of years. You keep doing that. That's what it means. I hope it's clear enough for everybody. Good. So now if I want to solve cosine x equal to 0, and now this in the middle there I have my x-axis, the crossing. Oh, this thing can piss me off. Why don't you want to disappear? You're still there. Okay, I assume that this is my x-axis, is somewhere here in the middle. It goes like this. Okay, you see, so the number of each time the function will intersect with this horizontal line, that is the root of the cosine function. I hope you understand what I mean, what I'm saying. So meaning that you can be given, you can be given time until you pass on to compute all these roots. You never. Your children, a great, grand. After thousands of, they will never stop. They will keep computing. That is the beauty of mathematics. You see that in math, you sit there in a few seconds, you write everything down. Wow. The people who did this, oh, my colleague, oh, they are geniuses. That's the power of mathematics. In a twinkle of an eye, we just write the solution to that. Okay. Now, if you look at this, when will cosine be 0? This axis, the x-axis, represents the cosine axis. So this point M of coordinate xy, each time it is aligned with the x-axis, with the y-axis, because if I project for this to be 0, I need to be on the y-axis. So if I'm here on the y-axis and I project here to read the x value is the cosine, right? Cosine will be 0. So each time, if I rotate like this, each time the point will be here or there, it will give me the value of x. Similarly to this position here, when this graph will intersect with the x-axis. All right. Okay, by periodicity, these 2 points, I can call them, I can write the general formula for that. So these 2 points, I can write that as n plus 1 pi by 2. Right. And this n is an odd. Okay, to indicate that it's odd, I can put 2 here in front, 2n plus 1. Oh. So I can say 2n plus 1 pi by 2. You see it's odd. Here, the factor here is 1 and here is 3. You can see. So if I take n equal to 0, it gives me pi by 2. When n is equal to 1, it will be 2 plus 1, 3. Then I'm here, 3 pi by 2. Now, the next time I reach here, I will be adding pi to this value. If I add pi, remember, the angle from here to there is pi, right? It's pi. And now from here to get here, I add another pi. So each time I add pi to move from here to there and from here to there, I add pi, 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 pi. So if I add pi to this 3 pi, well, it will be 5 pi. You can see here. 3 pi by 2 plus pi will be cross multiplication, pi by 2. So that would be 2 pi by 2, and this is pi. If I add this, it will be 3 pi plus 2 pi, it will be 5 pi. So 5 pi on here. 5 pi, and I add, if it is 5 pi, 5, I add another one, it becomes 7 pi. From 7, 9 pi, and then 9, 11, and so forth. So it will be there. See, now I will write this, and I say that this n can be any integer, positive or negative, because I can go in this direction. Okay, I can rotate clockwise. If I rotate clockwise, it becomes negative, then n will be negative. Now, if I rotate counterclockwise, which is the positive direction, trigonometric direction, n will be positive, right? So all these will give me all the roots. That's why I say with mathematics, you just write that. It covers all these values forever and ever. Once you say that you have this, finish. All these roots here are represented in this formula. So this is my x sub n. All these roots here, all this intersection, all of them, from negative infinity there, when everything began, in the beginning, towards the end, at the end, everything is here. Even if you take billions of years, they are all here. They are all written here. Ah, that's the power, the beauty of mathematics. My colleague, oh, geniuses. Eh? All right, so that is it. So that's what you have there. So you see, that's exactly what I wrote here. So this angle, which is n theta, of course, n theta sub k to indicate that it depends on this k, right? K. What I call n here is our k. Eh? This is our k. So because this angle, which I call x sub k, is n theta sub k. So you can see that this, which is our x sub k, is given by this. And this, what we denoted above by n is k. You see, it's there. So everything is written here. Everything. Eh? You can be dizzy when you look at this. Right? Okay, but in a single line, this is how you write all these roots, all of them, all. With all the explanation I gave here, they are written in this single line. Good. And you divide by n. Oh, yeah. And then you divide that by n, which is this factor. Divide by n, then you get your theta k is given by this, right? Because I said that this is xk, right? So if cosine xk is equal to something, this one, that's 0, and then we wrote that our xk is this one, n theta k, like this, and so if I write this theta, we know that theta k itself is cosine inverse, if you recall. This is cosine inverse of what? Of x, or xk, something like that. Yeah. So if I solve from here, I apply cosine on both sides, then I'll have cosine of x here. Sorry, cosine of x sub k. I apply cosine here. Sorry, this is theta. I apply cosine on both sides. This will give us x sub k. Okay, so we have this, so we divide. This is what we have. So if we divide this by n, we can take that n in the denominator, so that's what we have here. And this is theta. And what is theta? Theta, as we wrote here, is cosine inverse xk. Right, so I need to apply cosine on both sides to get my xk, right? This one. So if I apply cosine here and there, I get xk is cosine of this value, which is my theta k, right? So it will be cosine of this, cosine. So now, okay, something else, because to see this, okay, we use this information. We use the fact that, please, this xk and this one, they are different. This is just to denote that this is how I'm solving. Oh, sorry. The x that I wrote here is just to indicate that I'm solving cosine x equal to 0. But this x is not the same, because remember that in our definition of theta, we define in terms of x, right? So that's why here when you write this is not this x, right? I could have written just x here to avoid confusion. I could have just written that one. So I'm emphasizing on that so that people do not get confused. I can just put x there, yeah. Okay. Okay, now remember the range of our of cosine. When you write this, what is the range? If you recall in the definition of cosine, when I say if you want to write that cosine is invertible, what will be the range of theta? The argument of cosine is 0, pi. Never forget it, because if you don't know that, you will not be able to write this properly, and you will not get the number of roots. It is because we know that the range, when I say the range, the range of the argument here is 0, or the domain, if you want, from 0 to pi. Now, if you take this information, if you take this and impose that it's between 0 and pi, you will see that k will only take this finite value. Originally, we know that k runs the entire set of integers. But by imposing this second condition, you take this, that is, let me write it down. So here we are saying pi. Now you take this expression, which is this. So that would imply 2k plus 1 pi by 2n is there. Obviously, you can divide by pi. You can divide by pi throughout, so get rid of pi. Then solve for k. If you solve for k, you see that the possible values that k can take are these. And if you count the number of values, you have exactly n values. So that's why we can conclude that there are exactly n roots, which is what we wanted to prove here. So there are exactly n roots. And we can rearrange those roots. You can see. We can if we take this n, for the least square method, if you recall, for the least square method, we replace n with this. Count here. For the least square method, remember the roots. You count from 0 to n. These are the roots. So in total, how many roots do you have here? You have capital N plus 1. So if you take this n, substitute as capital N plus 1, there it will be 2n plus 2. And that's what you have here. Okay, so that's what we have. Sorry. So your x for the least square problem, you see that this k run from 0 to n. So from here. So if you readjust this, this is what you get. And this is important for the continuation. Okay. Now, if you come back to the general form of the function, we take this jk to be tk, our Chebyshev polynomial. Now, if this is a Chebyshev polynomial, remember this is a polynomial of degree k. Tk is a polynomial of degree k. Now, if you take this combination, you see that the highest degree, the highest value of k here will be n. Meaning that if you take the sum of all these polynomials, this will be a polynomial of degree n. Right. So I repeat, this gx, if you replace gk with tk. So if you take gk equal to tk, this is a polynomial of degree k. Of degree k. Now, if you take the sum of polynomial of degree 0, 1, 2, up to n, the final is a polynomial of degree n. So that's why instead of denoting it by gx, you can already specify that this gx, in fact, is a polynomial of degree n. So that's why we are writing here. And that's the least square, I mean the Chebyshev approximation polynomial. Now, this is what we have. And we know already from the least square, we don't need to perform the least square again. We know, of course. Now, this is a homework. Please, I will ask you to add this. You are supposed to submit. It's already time. You're supposed to submit. I gave you homework for Friday. I hope you haven't forgotten. Hello? Okay, so I'm adding to the homework another one, but this one you submit this after 2 weeks, right? After 2 weeks, you submit this homework. Right. Now, this is the orthogonality property of the Tn, Chebyshev polynomial. You can see here that you have another one. The first one was orthogonality in terms of integral. Here you have integral. And the points here are continuous. We are taking continuous point. But now here we are using discrete point. You have to make the difference. Now you can see that here we are using sk, this one. You have discrete point, right? discrete point, therefore the integral is converted into a sum. Now, using discrete point, this is your orthogonality property. But if you have a continuous point, continuous point that is point on a continuous interval, -1, 1, then orthogonality properties in terms of the integral. And that's what we discussed about in the beginning of the class. So you have this one. This is an orthogonality property for continuous point, or point in a continuous interval. Now this is for discrete point. And this also is an assignment or homework assignment. Due date in 3 weeks. Due in 2 weeks, sorry, 2 weeks. Okay, 2 weeks meaning, let me tell you exactly when. 2 weeks. So I add 14 to 3, that would be 17. Around the 17th September. Oh, it's too far. If it's too far, I can, too far, 14? Is the 14 okay? You student, eh? Now you can talk. Okay, we'll stop here for today. Thank you for your kind attention. God bless you. And see you on Friday. Bye-bye. I hope you enjoyed this class. If you did not enjoy it, I really enjoyed it. And I hope you did it also.
Bye, sir. Have a nice day.
Thank you. Same to you. Cassiope.